Okay, hello everyone. This is the second part video recording of meeting 3. So if you are watching this video without watching the first part, make sure that you watch the video recording of meeting 3 part 1. You see part 1 is split into two parts, two recordings. Now I will continue from where I left in the first recording. Primitive data types. See, this slide provides a summary. Now, no need to memorize the values, but these are just for you to understand what do I mean by the size of the data. You see, a byte is only 8 bits, means 8 possible digits, either 1 or 0. So this gives you a combination. The combination is going to spread from -1 to 8 to 1 to 7. So if you declare in Java a byte, you are limited to the following range. You cannot have, for example, 1670. It will not fit. So 1670 needs at least 2 bytes, because see the values of the 2 bytes. So a short is bigger than the byte. And what we are mainly using is the int for integers, which is 4 bytes. It gives you a number from -2 billion up to 2 billion something. If you need much larger values, you have the long, but it is limited to 8 bytes only. For real numbers, we have used the double, which is the biggest real number value you can get, and it gives you high accuracy up to 15, 16 decimal places. The float up to 6, 7 decimal places accuracy only, because it takes only 4 bytes. Now the char, if you take a look at the char takes 2 bytes. It's similar to the short, but it is used to represent characters. And the boolean, it's just true or false. So it is implemented differently. The size is not very clear, so it only takes 2 values, true or false. Now, taking all of these, if you are working with byte, short, int, long, float, double, char, any of these value can be promoted to the next bigger size. This is explained over here. Like, for example, you see the byte. You can give a short value, a short variable, a byte value. You can give an int value, an int variable, a short value. You can give a long variable, an int value, and so on. Now the boolean does not get promoted. Now based on this, you can notice that everything will be promoted to a double. Now note something, that promoting along to a float, you are gonna lose some data. So this is not very reasonable over here. Anyway, ignore it. Just take some of the examples written below. We have seen a promotion where I can declare a double and give it like an integer value, similar to this one, double D equal to 3. You see, 3 will be promoted, so this does not give you an error, and you do not lose any of the values. Alright, now some additional examples about division, modulo, and casting, and make sure to solve all the exercises. This is very essential. This was discussed in the previous session. Now I would go to testing two strings and comparing strings for equality. Let me go to NetBeans. I will create a new project. Next, finish. Alright, now I have a new project. Again, the usual. Let me remove the annoying comments, and let me just keep the main Java code. I will declare string, this is word 1 and word 2. Now let me give them values. Word 1 is equal to, let's say for example this is hello, and word 2 is equal to hello as well. Now if I compare these two, using equality, the answer is going to be very confusing, because it will tell you that yes, they are equal. The problem is that I am using a string literal. Alright, I am using a string literal. Notice, if word 1 is equal to word 2, provide an output statement, system.out.println the words are equal, else system.out.println the words are different. Alright, so now the way I wrote them using a string literal, alright, this condition would be true. But careful, this is not what we need. You see, the words are equal. This is not what we need. Now let me give you different strings. Uppercase, sorry, my mistake on the keyboard over here. The same mistake, alright. Uppercase H. Now if I run, the words are different because you see, lowercase h and uppercase h have different encodings. Now let me return it to lowercase h. Let me test one more time. The words are equal. Now this equality, never use it with the strings, even though it is working properly. It is wrong. Let me show you why. Let me show you why. I will take the words from the user. Here, let me remove the output. So let me provide a prompt, system.out.print enter 2 words, and I will take the word. Here it's not a literal anymore, so this is, oh, I need the scanner. Alright, let me declare my scanner. So this is import java.util.scanner. This probably should be part of each and every program. Scanner input is equal to new scanner of system.in, and now word is equal to the scanner is input dot I would use next semicolon, and let me take the word 2 from the user, so this is input dot next as well. Alright, so I am taking 2 words from the user using next. Each one is going to take a single word, and I requested 2 words from the user. Now I am performing my test. If the words are equal, let me run this program. Enter 2 words. This is hello, and this is hello. The exact same word, the exact same way it is written. Now it is going to tell me that the words are different. Well, why is that? When I used literals, they were identical. Now they are not. Well, the problem is that when I declare the type string, you see, string is not a primitive data type. It's not similar to the int, the boolean, the double. It is not a primitive data type. So this is my major problem. This is my major problem. I need to be able to test the strings and treat the strings as if I am treating the values of the string. In my previous example, now it's a little bit difficult to understand it. When I had a literal, Java created 2 references to the exact same memory location that included the string HELLO, all lowercase. Now this time, Java does not know that the user is going to provide 2 identical values, so they will be stored in memory differently. So this problem is that I am using equality to test my variables. Notice what I will do. I will use word 1, put dot, and write equals. I will open parentheses, add word 2 inside the parentheses. You see, this is the proper way of testing if 2 strings are identical or not. You write the first variable, word 1, you put dot equals, and you write the second variable, which is word 2. Now, if you take from the user two identical words, here, run, hello, hello. You see they are identical. The words are equal. This is what I need. Now let me test it again. Hello and uppercase hello. You see they are not identical. They are different. They are not equal. They should be identical, exactly the same case. And the same size. Like for example, hello and hellos. You see they are not equal. They are not equal. So the words are different. The words are different. Alright. So this is for string comparison. Now let me go back to the slides. With a string comparison, use the dot equals. Use the dot equals. And there is an example, the one I did. And be careful that we are taking them as input. You cannot test the literals. Alright, be careful when you test the literals. It's a little bit confusing. Try to rewrite it using printf and %s. This should tell you whether they are identical or not. Alright, now let me go to another part, how to test a single character. Now, instead of testing the character at 0, I will do both examples. I will test the first character, which is character at 0, and I will test the last character. Now, testing with characters is not dot equals. So let me do testing characters. And there is an exercise over here, testing for a word if it starts with A or A. Now this is very similar to the exercises that you have for this meeting. So anyway, let me tell you what this char at is going to do. Let me go to my NetBeans. I will keep the scanner, even though I will not be using it. Anyway, here's an empty program with a scanner, fine. And let me start by declaring two words. String word 1. I will use literals. I will not take input from the user. So just to see the words, let's say that the first word is hello. And string word 2 is equal to hi. Alright, semicolon. Now to compare one character at a time, I need to check if both words start with the same character. If word 1 dot, one of the methods is called the char at with an uppercase A, and you give it an index. You see the H in hello has index 0, the E in hello has index 1, the L2, the L3, and the O4. So char at 0. Now this is a single character. The character is a primitive data type, so you can use a quality test. Word 2 dot, I need to take the first character from word 2, so I use char at 0. System dot out dot print ln, both words start with same character, else system dot out dot print ln, the words start with different characters. Alright, here let me reduce the font. You can see the whole line over here. Now let me run this. Alright, so see both words start with the same character, and let me use by instead. The words start with different characters because I am testing the word at 0. I am testing the word at 0. Alright, let me write other words such as Monday, Wednesday. Now I need to test if both words end with the same character. The problem is that the first character is easy. You see, both have index 0. But the last character in Monday, M is 0, O1, N2, D3, A4, Y5, because we start at 0. And in the second one, 0, 1, 2, 3, 4, 5, 6, 7, 8. Both words end with the same current. Both words end with different characters. Now let me run this. You see, both words end with the same character. Figuring out this 5 and the 8, what if the value was given from the user? So there is a way to programmatically figure this out. You can take the word 1 dot length with parentheses and subtract from it 1. You see, 1, 2, 3, 4, 5, 6. I have 6 characters. This is the length. Length minus 1 is going to give me the last character. And I can do the same for word 2. Here, let me put the equality over here so that just you can see it. And make sure that this is word 2 dot length minus 1. Now let me modify the words. Let's say this is Thursday, and let's say this is the Friday. You see, now I am testing different words. Both words end with the same character. Let me put over here hello. Both words end with different characters. Alright, so I just showed you how the char at works and how you can go to the last character. Even though this is not really explained in this meeting, it will come at a later meeting. So just make sure you know how to test for the first character. This is more than enough. And if you'd like, I showed you how to test for a different character or the last character in a word. So definitely this is start. This is start. This was my program, whether they start with the first character or not. And here's a sample run. They start with different characters. I have the T and the H. Alright, now let me go back to the presentation. So testing characters for equality, and char at 0 returns the first character. Now this is testing for A. You have another example in the slides. Now let me go to compound operators. Compound operators is a little bit easier than what we did. You see, compound operator, you are doing the two operators together. You are joining them. So in C equal 5, if you do C equals C plus 3, means take the 5, add to it 3, so C will have 8. C started with 5, now it has 8. Now this over here, these two lines, they are equivalent to the following two lines without the comment. No need for the comment. You see, int C equal 5. Instead of writing C is equal to C plus equal, add to the value of C3. So now this is the same as writing C equals C plus 3. You can do compound operators with plus equal, minus equal, division equal, times equal, percent equal. You have a summary over here with an excellent example given what the variables are, given the memory location, and what way they will happen after the expression, and there's the explanation of the expression. So you can make sure to study the following slide really well. This way you will understand these compound operators. Now increment and decrement. The increment and the decrement. A plus plus and A minus minus. You see, A plus plus is the same as A equal A plus 1, means add 1. A minus minus is the same as A equal to A minus 1, means just remove one item. You can write it as a plus equal 1. It would be the same, you see. A is equal to a plus 1, or a plus equal 1, or a plus plus. They are all the same. You can check the example, make sure to read this properly. This is called a unary operator because you have only one variable and you are just applying this operator without any other operand. You only have one operand. Alright, now I will go to the last part of meeting 3, which is repetition. We have two different types of loops. For while loops, and while loops come in two different flavors, and we have the for loops. Now there are no additional exercises on loops, and while loops there is even no example for it. However, I will discuss the logic of the loop, and this will be discussed. While loops will be discussed later. The for loop, I will do an example which will be more than enough for this tutorial. So a while loop means that I need to repeat a set of code. The keyword is while, and similar to the if, you put parentheses and you put a condition. The condition could be more than one using and, or, XOR, or the condition could be a single condition only. And a condition was always going to be either true or false. For example, while number is less than 10, so as long as number has a value less than 10, the condition should be true. Keep on repeating until the condition is false, you go out. Notice the arrows. These arrows are excellent. Try to focus on them. You see this loop condition, if it is true, you go to the loop body. If it is false, follow this green highlight. You went after the loop body, and there should be statements over here to continue them. Now what to do when you finish the statements of the loop body? Once you finish, you go back and test the condition again. You finish, you go back and test the condition again. Now let's go to the for loop, which is a little bit more difficult, because the for loop has a lot more sections. You see the structure of a for loop. You have initialization, which is a single statement done only once. Then you have the loop condition, which you need to keep on testing. If the loop is true, go to the loop body. Just like the while, condition true, go to loop body. Now there is one addition for false statements. When the loop body finishes, it goes to another step, the action at the end. Now this action at the end in the while loop should be inside the body. In the for loop, it has a location for itself. And when you finish it, you go back to the condition. So do the statements, do the action, back to the condition, do the statements, do the action, back to the condition. Once the condition is false, go outside the loop body. I will do some examples, but this is the first example. We can do it over here, and then I will go to NetBeans. You see, for int I equals 0, this is the first statement. I less than or equal to 5, this is the condition. This is the loop body. It has only one statement, print welcome to Java, and then I++. Alright, I will explain more in my NetBeans. Let me go to NetBeans, and let me start a new project. Here, let me close all projects, file, new project. I'm not giving them real names, just next, finish. Doesn't matter what the class name is. We will worry about naming classes in M251, not in TM105, in object-oriented programming. Currently it's called M251. It might be called something else at a later time. Alright, so this is my attempt to understand for loops. Let me start by writing a for loop. The keyword is for, F-O-R, and I have 3 sections separated by a semicolon. The first section is for initialization. Assume that I had variable I declared previously. If this is the variable to be used in the for loop, you just give it the initial value, I equals 0 semicolon. You see, this is the first value. So start with I equals 0. This means that before checking the condition, this statement needs to be done. Now I less than 5, semicolon, I is equal to I plus 1. You see, this is a for loop, and let me put a body for the for loop. By the way, if the for loop has a single statement, no need for this block. You can remove this block and just write a single statement similar to the if. Now I will do some modifications, but first let me trace this one. System.out.println, print the value of I. You see, I do not want to print the statement. I want to print the value of I and to trace the loop. Let me run it. Check the output. You see, I started with 0. This was done. Now I has the value 0. Is 0 less than 5? Yes. Then go to the loop body. System.out.println 0. So here's my first 0. Then the loop body finished. You go over here. I is equal to I plus 1. Now the value of I is 1. Is 1 less than 5? Yes. So you go to system.out.println I. So let me pin this over here. So this is the second value of I. It is 1. Now the loop body finished. You go to this statement. I is equal to 1 plus 1. Now I is 2. You come over here. Is 2 less than 5? Yes. Print 2. Prints 2. Now you go back to this action statement. Make the I 3. Is 3 less than 5? Yes. Print the I. Here's the 3. Now you go back to this statement. I is now 4. Is 4 less than 5? Yes. Print the value 4. Then you go to this statement. 4 plus 1 is 5. Is 5 less than 5? No, they are equal. The condition is false. You do not print. You see, it did not print the 5. So when did this stop? When I became 5. Alright, let me do a few modifications. First of all, we know that I equal I plus 1 could be written as I plus equal 1, or it could be written as I plus plus. Well, usually in for loops, this is how you see it. Means add 1 to I, add 1 to I, add 1 to I. Now this variable, why declare it outside the for loop if it is to be used only for this loop? Put the declaration over here. You see, this is exactly the same. Here, run it. This is the same output. The same output. Now, reading a for loop from its signature, you should be able, I will put a comment, to read the for loop from the signature. You see, you are starting with 0. You are increasing by 1. So this is 0, 1, 2. When do you stop? You stop when this condition becomes false. So it is true for any value less than 5. So 3 less than 5, yes. 4 less than 5, yes. And that's it. You see, the values of I are going to take all the following: 0, 1, 2, 3, 4. Now let me do another example with different values of I. Let's assume I started with 3, I less than 15, I plus equal 2. Again, trace it. You see, the first value is a 3. You are increasing this value by 2. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2, 11. 11 plus 2, 13. You see, 13 is still less than 15. 13 plus 2, 15. But be careful. Is 15 less than 15? No. So this value is not gonna be printed. The for loop is going to run for these values of I only. It will run 6 times. 1, 2, 3, 4, 5, 6. So reading the for loop should give you an example of how many times. Here, test it. You see, this is my run. 3, 5, 7, 9, 11, 13. These are the values that I have. Alright, let me go back to the slides. You see, this was our first example. Start with 1, less or equal. So 1, 2, 3, 4. Is 5 less or equal to 5? Yes. 6? No, it will not run, because 6 is greater than 5. So this will run for the values of I 1, 2, 3, 4, and 5. This will run 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You are testing for equality. So here are the values. Print the values of I. You can write a for loop in reverse. You see, you started with 10 and you are decreasing. So this is 10, 9, 8, 7. The last valid value is any value which is larger or equal to 1. So the last valid value is 1. Make sure to try this out, change the values, and see if you know how many times the loop will run. Now, inside the loop, you can put an if statement. And these two are equivalent. Let me explain why. I will go to my NetBeans. Alright, let me write the for loop. I need to know the values from 0 to 10. Let's assume 10 inclusive. So let me put less or equal to 10 if they are even or not. Let me put an output statement before the loop. System.out.print ln. Alright, so this is print ln. The following numbers are even. And let me write over here, if I modulo 2 is equal to 0, if it is divisible by 2, system.out.print, and let me put over here I, but I will add after I a space. See, I did a little bit different than the slides, but still the same logic. So I will test all the values 0, 1, 2, 3 up until 10. If the number modulo 2 gives me 0, then I am printing it. It is even. 0 modulo 2 is 0. 1 modulo 2 is 1. It will not be printed. 2 modulo 2 is 0. It will print 2. 3 modulo 2 is 1. It will not be printed. So run it. The following numbers are even: 0, 2, 4, 6, 8, and 10. If you want to have an empty line after the for loop, you can write system.out.println, keep it empty. This is println, keep it empty, run it. You see, now they are on a line by themselves. Okay, what they are telling you in the slides is that you know that Since you are starting with 0, you know that the even numbers, you are skipping by 2. Why use this test? Keep it without the test, and instead of adding 1, I plus equal 2, add 2. So now 0 is even, 2 is even, 4, and you are not doing any test. Run it. You see the same result. You just modified this one, and you saved yourself from using an if statement. Alright, back to the slides. These are the two codes that I just did. Now try writing a code to print the odd numbers from 1 to 9. This should be easy for you, and try to do it from 9 to 1. This is an excellent exercise so that you can try it out yourself. So try to do it yourself. Let me do 9 to 1 for you using NetBeans, but try to do it. Do not watch the video now. Try to pause the video, try to do it yourself, and then come back to the video. Alright, hopefully you tried doing it yourself and came back. The following numbers are, let me put odd over here, and let me rewrite the whole loop. I will write it using the modulo first. So this is 4 int I equal to 9 semicolon, I greater than or equal to 1 semicolon, I minus minus. So this is taking all the values from 9 to 1. Say 9, go down to 1, subtracting 1. So 9, 8, 7, 6, and it is greater or equal, so 1 is included. If I is your variable, modulo 2 is equal to 1, because if you have 1 as a remainder, means it's not divisible by 2. Something that is not divisible by 2 is odd. So system.out.print I, and put some sort of space, system.out.println. Here it is empty. Run it. The following numbers are odd. Alright, let me write it the other way. I will remove this if, and I need to make sure that all the numbers are odd, so I need to be subtracting by 2. So this is minus equal 2. I am now subtracting by 2 and just printing the values. You see here's a run. This is the same result. Alright, now back to the slides. This is an example for taking a grades of 15 students. You can try it out yourself. I will not be working with this example. This is because for loops you will have more exercises on both for and while in meeting 4. So this is just meeting 3, introducing for loops. Now let me go over here to precedence. I have introduced this slide before. Now you know all the operators. However, be very careful. This is a little bit confusing. This is the problem is that you see over here there are two ways you can put it before the variable and after the variable. So it's a little bit confusing over here. These should be at a later stage, because we did not take them when they have the highest precedence possible. So just ignore these at the time being and focus on the remainder, on the last part available. Now no need to know all of them in details. They are somehow logical, and there is an example over here. You see, when you check the following value, you have two expressions, and you are checking which one is greater. So Java is automatically going to assume that this is the first expression and this is the second expression. So it will do this at the end. It will do the comparison at the end. So basically you definitely start with parentheses, then you go to the multiplications, then you go to the addition, subtraction, and finally you go to the comparison. So you can check this code and the result is going to be false. This is self-explanatory. Alright, this is it for meeting 3. Make sure to solve all the exercises. They are in a different file available on the CLMS. I have solved most of them, but they are all extremely important. Make sure to solve them all. And this is it for meeting 3. Thank you for watching this video.